Okay, good morning all. Myself Dr. Abdul Pasha, Assistant Professor, Institute of Aeronautical Engineering, Hyderabad. I am going to make presentation on the course Power System Operation and Control. In this course, you are going to learn how power system network is operated with various control strategies and the methods implemented to go with the smooth working operation of the entire power system network. Coming to this course, the first topic starts with Introduction to Power System Operation and Control. Coming to the course, here are some course outcomes which will define the course to the students. At the end of the course, the students can able to learn these outcomes. The first outcome is CO1, course outcome 1. Here, we will solve the optimum load scheduling with various constraints in thermal and hydro power stations using conventional optimization techniques and general transmission line loss formulas. Second course outcome CO2 is designed to develop the mathematical models of the mechanical and electrical components, which will be takes place in a power generating sector for deriving the transfer function of the power system network. Coming to course objective 3, distinguishing the single area and two area load frequency control for minimizing the transient and steady state deviations. This will be done with the help of various control strategies. Next, coming to the CO4, course outcome 4. Here we will choose different types of compensating equipments for controlling the voltage, reactive power term, power factor. So all these will be designed for improving the reliability in compensated and uncompensated transmission lines. Coming to CO5, course outcome 5. Here we will interpret the types of the loads in the power system network from their characteristic factors. Coming to the last CO, that is CO6. Here we will understand the real-time control of power system networks. So these are the 6 COs introduced. At the end of the course, the student can withstand or they can mold these COs. Next, coming to the course overview. This course will enable the students to analyze various parameters, so which will affect the operation and control of the power system network. It will deals with the control strategies entirely. We will introduce so many controls here to meet the load demand and to get the targeted generating output and distributed power in the interconnected system, which will impact economically and improves the reliability of the system. By that, maintaining the frequency and voltage with the suitable limits, the factors which will influence the power generation at a lower cost. They will supposed to operate with much efficiencies. By this, the resultant is fuel cost, transmission losses, steady state flow of the active and reactive power will be improved. Here we will deploy some new optimal dispatch solutions, which will be helpful in finding the optimal dispatch of the generation. So this is supposed to be useful for an interconnected power system network. So all these are the course overviews. And coming to course objectives, the main course objectives designed here are economic operation of the power system network, which will be mingled with the hydrothermal scheduling, modeling of the turbines, generators, and automatic controllers. Here we will introduce single area and two area load frequency control system. By this only we can obtain suitable efficiencies. At last we will analyze the reactive power control and load modeling process. So here it is discussed with the course syllabus. It is designed with 5 modules. Module 1 contains economic operation of the power system network. The economic operation of the power system network is designed with the optimal scheduling of the thermal power system. Here in this, we will introduce optimal operation of the generators in thermal power system networks. It goes with some parameters called heat rate curve, cost curve, incremental fuel costs, and production costs. These will define the performance of the power system network. And these are analyzed with input and output characteristics. Here it should be designed with optimum generation allocation. So these are to be one of the constraints without and with transmission line losses coefficients. So here we will introduce general transmission line loss formula. One of the method called unit commitment. With this unit commitment case, we can make the optimal scheduling for particular hydrothermal power system, hydroelectric power plant models, scheduling some numerical problems, and short-term analysis of this hydrothermal analysis. This course of module 1 entirely deals with the economic analysis of the power system network. Coming to module 2, this involves in modeling of the governor mechanism, turbine system, and also excitation systems. So coming to the first case in the module 2 of modeling of governor mechanism, it involves in mathematical modeling for the particular speed governing mechanism and some derivative analysis of small signal transfer functions. Coming to second case, modeling of the turbine, it deals with the first order turbine model. This should be analyzed with a suitable block diagram for steam turbines, and they will be framed with linear models, approximated linear models. This will design the case of modeling of the turbine system. Coming to third case in module 2, modeling of the excitation system. So the modeling of the excitation system will follows with fundamental characteristics of a particular excitation system. First we will define the fundamental characteristics here. Based on that we will derive transfer function, and this will be analyzed with the block diagram by utilizing the concept of IEEE type 1 model. So this module 2 entirely involves in modeling or designing of this governor mechanism, turbine mechanism, and excitation systems. This is module 2. Next, coming to module 3. Module 3 is associated with only two major cases, single area and two area load frequency control. So here load frequency control is one of the method which will be designed in the power system network to go over the control. So here load frequency control of single area system is considered in the first case. So here we will suppose to learn necessity of fixing this frequency constant and some parameters related to control area. What is control area? What are the parameters associated? What is single area control? What about its block diagram representation for a particular isolated power system network? And we will go with the steady state analysis for the single area load frequency control system. We will define the dynamic response in terms of its input and output characteristics. What are controlled and uncontrolled cases in this system that we can define in this case. So all these are the parameters which are relevant to the single area load frequency control. All these are the parameters related to single area load frequency control. If you go with the multi-area load frequency, that is a two-area load frequency control, here we will consider uncontrolled case and controlled case. In this, mainly we will say about tie line bias control with suitable controllers introduced. One of the suitable controllers introduced here are proportional plus integral control, that is simply termed as PI control action for single area, and its block diagram representation. We will make the steady state response of that system. How load frequency control is happening for two area, and what is economic dispatch that is taken place in this two area load frequency control. So all these parameters will be introduced in this module 3 case. So this entirely deals with single area and two area load frequency control. In this we will go with the parameters associated with one and two area load frequency controls. Next, coming to module 4, we will take here compensation methodologies for the power factor improvement and a reactive power control case. We will introduce compensation strategies, means in terms of its power factor and reactive power, it is very much important in the power system network. When only the suitable limits of the power factor and control over the reactive power can only make the smooth working operation of the power system network. So it is associated with the parameters called voltage control. The voltage control is given for equipment, and it is considered with effect of series capacitors. So what is the importance of using this series capacitors? Means they will improve the power factor of the system. And line drop compensation methodology we will discuss here. And we will introduce automatic voltage regulators to control over the voltage for a given system. We will introduce these systems called AVRs, automatic voltage regulators. So here power factor control is done by different types of power capacitors. They can exchange the voltage. They can exchange suitable amounts of voltage. Here the classification of power capacitors are shunt and series in nature. So here we will consider effect of shunt capacitors. They will be fixed and switched in nature. And we will make a correction in the power factor. Whenever there is a lagging of the power factor case, we need to make it as a leading case. So we will go for one of the method called power factor correction. So because of this, you can maintain your power factor under suitable limits. We will make the capacitor allocation here. Wherever the system lags its response, at that instant we will introduce go for capacitor allocation. Economic justification, and we will introduce some procedures to determine the best capacitor location. Based on that allocation procedures, we can suppose to introduce the capacitor wherever the system lagging its response. So this module entirely deals all the compensation strategies for only two factors, two parameters. Those are power factor and reactive power control. Next, coming to module 5, the module 5 completely goes with one of the load compensation strategies. So what is load compensation strategies means? This load compensation strategies involves with the characteristics of the loads. Before going for load compensation method, the characteristics are designed for various loads and what are the factors associated with them, and we will make the relation between the load parameters called load factor, loss factors, and we will define some specifications here. This can be done by one of the load compensating devices. So all these load compensation benefits will be applicable for different types of the loads. So here the loads may be existing in nature are residential, commercial, agricultural, industrial, like this. So all these are the loads which will be available in the nature. So for this classification, we will make the one of the load compensation strategy by introducing their characteristics, whatever it may be the type of the load. Characteristics are important here. So with that characteristics only, it can be easy to compensate the load. The compensation strategy is based on only the characteristics. The characteristics will define how the load behavior. This load behavior can be determined by obtaining the characteristics of the loads. Next. So all these are the information regarding the power system in operation and control. Now we will start our course with introduction. First we will discuss what is the importance of power system operation and control. Here we will go with thermal, idle, scheduling processes. The main aim here introduced with power system operation and control is to maintain the continuous supply of the power. So here continuity of the supply is required for the load with suitable quality to all the consumers, whatever it may be the consumer. It may be domestic, it may be commercial, like that. Whatever it may be the consumer, continuity of the power supply is required. So when the system is in equilibrium condition, there should be a balance between the demand and the generated power. We should look into this. Whatever the amount of power generated should meet the demand. Should meet the demand. Then only we can achieve power balance. The amount of power generated should meet the criteria of the load requirement or load demand. So this will be done with the constraints which will be introduced in the power system operation. with various control strategies. So directly we cannot go with this requirements. We cannot meet the requirements of the demand, load demand, without considering the constraints of the control strategies. These can only achieve the load demand or load requirement. So here we will define what is this power system operations and the control. So coming to the term power system operations, this is basically a term used in electricity generation, which will describe the process of decision making. So here we will decide based on the time scale factor. This may be happens for 1 day or 1 minute, whatever it may be the time factor. So day ahead operation is taking place here. So which will be prior to the power delivery. So here power system control means which will describes the actions taken in response to the unplanned disturbances. Whatever the procedures we are going to implement for suitable unplanned disturbances. What are these unplanned disturbances means? Changes in the demand, or it may be equipment failures, like that. So in order to provide suitable or reliable electric supply, we should go with the power system control operation. All these are the unplanned disturbances. So what are unplanned disturbances means? Changes in the demand and equipment malfunction. We cannot expect the changes in the demand. The demand may be changes, variable in nature. Sometimes the equipment may goes to malfunctions. So all these factors come under the group of unplanned disturbances. So the solution for this unplanned disturbances are supposed to be handed over to the power system control operation, which will look into this and makes the system in a right manner. And due to this, we will obtain reliable electricity supply. So all these procedures and all these combinations, which will be kept in a corresponding engineering branch, is supposed to be defined with power system operations and control. We will introduce various controllers here in this. The controllers will look into these all disturbances or changeovers, which will keep all these system considerations together in a single place and make the reliability of the power supply. And here one more point we need to remember, that this is very difficult to store the electricity. So we are in the AC in nature, regular usage. DC we can store to the limited extent, but coming to AC, the usage is more with the AC supply. So this will be very difficult to store. So at any moment, supply shall be balanced with the demand. This can be achieved with a grid balancing condition. So in electrical grid, what is the main task here is means real-time balancing. When the system is under operating, whenever there will be a generation and it will reaches to the transmission network and meeting to the load requirement means all this process entirely goes with real-time balancing procedure. Real-time balancing procedure. So what is this real-time balancing procedure means? Meeting the load requirements. For meeting the load requirements, whatever our generated power, that should be balanced with this. Whenever imbalances are taken place, meanwhile the control operation will be handed over. The control operation will be handover in between generation and load requirement. This process is called real-time balance, which will be reached or performed by regional based control centers. They will take care about all these real-time balancing of the power system networks. The main functionality of this regional based control center is to whatever the amount of power generated, that should meet the load requirement. This can be look into the system by regional based controller centers. Now coming to operating status of the power system networks. Whatever it may be the power system network, it may be involved with hydel or thermal. It will involve in various blocks. The blocks here are normal state, restorative state, extreme state. All they will be interconnected to the one of the alert nature, that is alert stage. At final extent, whenever there will be a discrepancy in the system, that will be connected to the emergency state. The cyclic order will follow. So, what it enables means, for a given power system network, when it is considered with a simple state, that is normal state, it will be goes with restorative state to the extreme state. So when there will be any problem associated in these three states, the information is passed to this alert state. This will actuate the emergency state. So likewise the cyclic procedure will be happens. So all these states in state transition nature will activate the alert when there is any disturbance in particular block. That is called alert state. This will give the information to the emergency block. Likewise, the cyclic order will be repeats. Now coming to one of the procedure called optimal power system operation. What is mean by optimal power system operation means, this is related to the economic operations of the power system. What is economic operation of the power system? Economic operation of the power system means meeting the load demand, maintaining the cost, time spans. All these factors will decide the optimal power system operation. So here it involves with the various parameters, that is cost of real power generation, allocating real power at generator buses, optimum allocation of the units. This can be better studied in unit commitment problem. And optimum allocation of generators to the each power station network. So these procedures will be repeated in economic dispatch problem. So all these parameters will influence the optimal power system operation. Based on that only, we can go with the economic operation of the power system network. Next case is optimal scheduling of thermal power system. What is optimal scheduling of thermal power system? So optimal scheduling of thermal power system means it is ready to minimize the power production costs. Completely depends on economic operation of the power system. So it will be mainly impact the generation costs. So when it will be the case to meet the physical limitations and operational constraints on the power system components, it will be considered for power system control problem, which will operate over different time frames. Likewise, we will consider optimal scheduling of thermal power system. So, in order to reduce the total fuel consumption and optimize the scheduling time of thermal power system in thermal power plants, there will be a method called deep reinforcement learning theory. This will be introduced to design the optimal scheduling procedures for thermal power system. This method or this theory will introduce the scheduling procedures, how to meet the load demands with suitable generating costs, how to meet the load, how can we balance the load with the generated power. All these factors will be studied in deep learning theory. So, operation of any power system, it may be hydro or thermal, is however more complex. Why? Because if you go with the hydro power plants, they have negligible operating costs, but which are required to operate under constraints of water availability for hydro generation. This will be taken place for a given period of time. So here problem is it will belonging to the real time of the dynamic optimization procedures. So to minimize this problem, the operating cost of the hydrothermal process can be seen as one of the minimizing the fuel cost of thermal plants. So which will be considered under variable constraints of the water availability. So here it is fixed with the storage and inflow of the water. How much amount of storage in the dam, water heads, inflows, all these factors will be considered. So for example, there will be the dam, what is the head of the water, availability of the water, this will be treated as head. This will be under peak conditions during rainy condition. During rainy case, the water head is more, so there is no problem with that. So inflow is also high during this case. So this inflow will make the turbine impact. Next, what is fundamental hydrothermal power system? This diagram will better experiences how fundamental hydrothermal system is existing. Coming to this, the fundamental hydrothermal system contains, the first block is thermal plant. These are defined with one of the constraint called P suffix GT. And it is given to one of the block called P suffix D. This is the common sharing point. And one more thing is hydro plant. The sharing is kept in between your thermal and the hydro plant. This load will share the power produced from thermal plant and hydro point. This is kept nearer to the reservoir storage. The inflow is started from here, denoted with J. This is water inflow. This is connected to the hydro plant. Here we will maintain the discharge coefficient, that is water discharge Q. So what happens with the fundamental hydrothermal system means it consists of one of the hydro and one thermal plant supplying power to a centralized load. This is your centralized load. So for this centralized load, which will be treated as fundamental system, here optimization will be carried out with real power generation. It will be executed under control variables. Whenever there is any discrepancy happens in thermal power plant, the hydro power plant will look into the hydro load consumption case. So both the plants, they share the load equally. Here, when there is a block or outage for any power plant, then the next or other power plant will give the supply to feed the load. Likewise, the common power plants, they will share the load equally. Here are some of the mathematical formulations designed for a fundamental hydrothermal power system. These relations or formulations will make the suitable operation of the fundamental hydrothermal power system. So here the considerations are certain period of operation, that is capital T. The time factor may be 1 year, 1 month or 1 day. These are the time factors. So depending upon the requirement, we will select the time period. Here assumptions made are storage of hydro reservoir at the beginning and the end of the period are specified. We need to specify reservoirs beginning and end periods. How can we specify means? What is the capacity of the storage? At what extent it is happening? What is the level of the reservoir? Is it under peak position or lower the level or mid the level? These are the constraints we will define or we will specify. And the second case is we need to specify water inflow to the reservoir. How much amount of water inflow is coming to the reservoir after accounting for irrigation usage, and which will influence the load demand on the system. These two parameters will influence the load demand on the system. They are known to be the functions of the time with complete certainty, which will be deterministic in nature. So the problem here is to determine the Q of T parameter, that is called water discharge rate. So it cannot be fixed or constant. The flow may be continuous or discontinuous, or it may be varies. So it has to minimize the cost of thermal generation. To make this procedure, we should assume some constraints. So what are the constraints means? First one is meeting the load demand. How can we meet the load demand means? Here is a simple expression which will defines meeting the load demand case. What is that means? P suffix gt of T plus pgh as a function of T minus PL of T minus PD of T, which is equals to 0, which is T tends to 0 comma T. Under these time limits, the expression is defined. Means, what are these constraints means? The PGT is associated with thermal constraint, PGH is associated with hydro constraints, and PL is associated with load constraints, PD is associated with demand constraints. Every parameter, every variable is acting as a function of time. That is small t is represented here. So under these limits 0 to t, the constraints will operate. Your time factor is important. The entire relation is to be called by the name power balancing equation. Power balancing equation. So what is this power balancing equation means? Summation of all these constraints or coefficients, PGT as thermal in nature, PGH as hydel in nature, load demand and demand constraint. So all these summations will cumulatively gives one of the relation called power balancing equation. What is the resultant with this power balancing equation means you can meet the load requirement. You can meet the load requirement, load demand continuously when only all these parameters are existing. Without all these constraints, you cannot make the power balance. Next. Second case is availability of the water. So here availability of the water is much important. This is denoted with one of the expression x dash of t minus x dash of 0, which will be under integral time limits 0 to t j of t dt plus integral of 0 to t q of t dt, which is equals to 0, where j of t will defines the water inflow rate, x dash of t will define storage of the water, x dash of 0, x dash of t are one of the specified water storage parameters which will be happening at the beginning and the end of the optimization intervals. So to make this process in hydro generation, PGH of T is a function of hydro discharge and also water storage. It will specifies the head of the water, level of the water it will specifies. That will be denoted as PGH as a function of time, that is f of x dash of t comma q of t. We already discussed x dash of t is the water storage. Here q of t is the discharge coefficient. So here for hydro power, the constraint PGH as a function of time will defines f of x dash of t comma q of t. One will define the storage, another will be the discharge coefficient. Combined case as a functionality will gives you the constraint called PGH. Next we will go with some advantage and disadvantage of this hydrothermal scheduling process, which will be taken place in a power system operation and control. So the hydrothermal process methodology is very simple and it can be directly extended to a system having multi-hydro and multi-thermal plants. So multi-hydro, multi-thermal plants means they are interconnected in nature. Whatever it may be, which may be hydel or thermal in nature, they are supposed to be interconnected one each other. What is the advantage of interconnecting one each another? Means when these two plants are connected to a common load at any cost, when any one of the input is missing, that means any one of the plant is fails to supply the power to the load, then immediately the second case is ready to feed the power to the load. That is the advantage of using multi plants. Whatever it may be hydel in nature or it may be thermal in nature. They are ready to feed the power immediately. So this method has also one of the disadvantage. What it means? Large memory occupancy. Large memory requirement is there. So it is associated with independent variables, dependent variables, and one of the gradients. They need to be stored simultaneously. So this storing system will increases the space. That means memory. Memory occupancy is more. So for this, we are using a modified technique called as decomposition. What is this decomposition means? It will ready to overcome the difficulties faced due to this memory occupancies, which is ready to minimized by one of the optimization techniques. These are most important in the power system network, which will reduce the memory occupancy, which is carried out over each subinterval, and the complete cycle of iteration is repeated. Number of times we will make the iterations for every procedure, for every subintervals. Due to this number of iterations, we can optimize the system easily. If the water availability equation does not check at the end, then we cannot meet the load demand. We cannot meet the load demand. We need to check with the power balancing equation and water availability. These two are much more important. With these two factors only, you can reach the requirement of the load. So, once the requirement of the load is achieved, one of the optimization procedures, they will introduce various control strategies to meet the load requirement to the generated power. So, if you are unable to check the water availability and balancing of the power, then load requirement cannot be achieved. So with these procedures and methods, we can achieve the quality of the power. So what is the quality of the power means? It should determine the fitness of the electric power supply. We already discussed with voltage, current, quality, we can reach the suitable requirements of the load demand. That is called by the name power quality. So it defines the voltage quality, current quality with reduced harmonic distortions. So by this control strategies in power system networks, we can reach the suitable operation of the power systems. Thank you. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.